Hey, what's up YouTube? So back again for day 2 on the Python BACnet Stacks playground. I also wanted to just share something that this is coming next. So hopefully we can plow through the BACnet Stacks playground with our AI generated course content, and then maybe like this summer I want to do another one all about graph theory and data modeling efforts and how to use the brick ontology in ASHRAE 223P, maybe from a BACnet scan or even from like a database somehow or another. It's coming. It's like still needs a little bit of work in the course content created by AI, as with this BACnet, the BACnet project too. So this is it. This is the Python BACnet Stacks playground. Like we talked about yesterday on day 1, we'll be using the BAC0 and BACpipes 3 libraries, which are the Python BACnet Stacks. Just to maybe a little bit more context, maybe I'll just go to GitHub, BACpipes 3. So this is the underlying, it's like a networking stack for BACnet. Each coding language has their own BACnet stack. Java has BACnet for J, which runs on a JACE or like in the Niagara framework. There's also one in C called the BACnet stack. That's probably the most famous one. That's by Steve Karg. So BACnet stack in C. This one is for like embedded devices. So this is all in C. I have played around with this a little bit, and what's kind of cool on Linux is that you can compile it into you can compile it right on Linux. So like C is a compiled language, where when we play around with Python, that's compiled at runtime. So all coding languages I think get compiled, but the difference is that Python is a scripting language, which gets compiled at runtime, and then if you do something in C or Rust or Java, that gets compiled from the get-go, and it's a compiled app. But this is mostly, I think, for embedded devices. Like you would run this on, I'm running this stuff on a Raspberry Pi computer, just a Linux computer, so it's like embedded Linux, but I think you would mostly be shooting to run C code in like an actual embedded device, which would be like an RTOS, like a real-time operating system. You know, perhaps like our VAV boxes or our air handling unit controllers, our devices could be running the BACnet stack, and it's written in C. This is really hard to use unless you're an embedded developer, and C code I think is kind of tough. But Steve Karg here, he's pretty famous in the BACnet world, I think. He also wrote the Yabe, like yet another BACnet emulator. So if you ever heard of Yabe, BACnet scan tool. I think this is part of Steve. Steve did this, and it's written in C#, which is more like a higher level language, more like Python or Java, where you could also do everything we're doing in this course in C or C# if you're a C# person. But I personally like Python. I've been playing around with it for a good probably almost 10 years, maybe not quite that long, but for a while now. Mostly starting out as a field technician, I would play around with BACpipes and BAC0 on construction sites, kind of doing the same thing we're doing now. So, okay, so here we go. So we're using this Python BACnet stack, and it's a networking stack. So I think like what we mean by that is you could actually drill down, you don't need to know this stuff, but you could actually drill down into the source code of BACpipes, and there's just thousands of lines of code in here that are actually like parsing like network stack messages. So this is something that gets really deep into building a networking stack from scratch. I think is really complicated. Honestly, it's I don't know enough about BACnet to actually make a stack by itself, but enough to be dangerous in using it and making applications with it. So we're just using this as like an application framework, and like a whole nother level or two deeper is like people actually make the code that parses BACnet messages on the wire, like what you'd see on Wireshark and that type of stuff. So some of these type of people too, like, could be employed by manufacturers of HVAC control systems, and these people might not even know HVAC, but do have to know HVAC to make a BACnet stack and a protocol. So just keep that in mind. We don't need to dive into actually how the BACnet stack parses messages, because I think that's a whole nother lesson or two level above even my understanding of BACnet. But we should just have like a solid framework on how we use BACnet in building automation contracting. And to me, that if you have like a good 5 or 10 years in setting up BACnet systems and you're confident in what you're doing, and like we know how to use our BACnet scanning tools, that's all we need to know to be able to use these stacks, in my opinion. So this is the BACnet stack. That's actually, we're going to utilize this a lot. And then BAC 0, like we talked about yesterday, is built on BACpipes 3. So BAC 0 is like a wrapper library that wraps itself around BACpipes to make things even easier. And like I was saying yesterday, I'm very thankful that Christian Tremblay created BAC 0, because if it wasn't for that making it really easy, I probably wouldn't be here now. Because when I first started out trying to just do BACpipes from scratch, it was way too hard. And I was very thankful that Christian has a lot of very easy tutorials and things to help me out. So yeah, we'll get into this later, and mostly in the samples. So this is kind of some cool stuff in here, and you can actually make some of your own BACnet devices, which is a BACnet server, which we'll get into that a little bit later. Okay, so enough about that. Maybe we can just get into lesson 2 for today. Okay, so I have VS Code open already. In yesterday's video, we talked a little bit about how to install Python and set it up. I'm using Windows, which I think for this whole coursework should be fine, because the BACnet stacks even work on Windows, which sometimes you have to run things on Linux only, or if it was like the BACnet stack written in C, that might not work on Windows. So there might be a different way to compile on Windows, but I think everything we'll be doing here, Windows should be just fine. And I think it's kind of a nice way to do the course too, because most of the building automation technicians out there are using Windows. A lot of the BACnet stacks, or the BACnet scanning tools, everyone just does everything in Windows, at least in the HVAC controls contracting world. If you get into IoT and everything, that might get into more Linux, and a lot of developers use Mac. But I think Windows should be everything you need to know here. Okay, so let's get into it. So day 2, we're just doing our crash course on Python still, and it's very applied course in Python. Maybe I'll point out as the course goes on, but if you want a little bit deeper dive in Python, I would highly recommend Python edX, Georgia Tech I think Georgia Tech. Yeah, this one's really good. So if you want to do like a super in-depth Python course, which I highly recommend, you can even put it on your LinkedIn profile that you did this crash course. So this is like a full-blown like maybe computer science like 101 kind of a course, shareable credential on LinkedIn, which I did a long time ago. But it's really nice. We're kind of covering these same topics here, but very applied. So this goes deep into just the syntax, loops, and data structures, and some basic algorithms, but it's much more in depth. And so we're just doing some applied version of this. And if you would do, which is not getting into data science or advanced computer science courses, that would be advanced data structures, advanced algorithms, and even getting into machine learning algorithms. That's more like master's degree level computer science, from what I can tell. So we're just doing very entry level applied version of this. So I'll link this in the description too, but when I first started out, this really helped me. And then like once you do all of this computer science 101 course, then there's even better courses out there where you can do software engineering, where you're actually building projects, where you're making web apps, where you're or if you want to do data science, you can kind of branch off from here. But I would highly recommend doing some basic computer science courses in the data structures and algorithms, having like a solid foundation in that. Even the most basic computer science 101 level, it might be all you need. That's all I need for myself, is like I'm not really getting into machine learning or cryptography or any advanced data science algorithm stuff. Like I'm mostly just using just really basic stuff, which we'll cover here. So do this if you're just starting out. Highly recommend it. Okay, so let's get back to it. Okay, so the goal for today is just studying variables in arithmetic in Python. So the math is built into every coding language. But if you want to use advanced math libraries, which on the previous course in Optimal Start, we started running into the limitations of math libraries. But every coding language has math built into it, the ability to do math. Okay, so the goal here is to learn how to store values in variables and perform arithmetic operations. By the end of the lesson, be able to write simple Python expressions to calculate sums, differences, products, divisions, remainders, powers, and assign the results to descriptive variable names. In Python, you assign a value to variables using the equal operator. Variable names can either contain letters, digits, underscores, but must not start with a digit. Comments begin with hash and then extend to the end of the line, allowing you to document your code. Python's arithmetic operators allow mathematical notations: plus, minus, multiplication, division. Operators all behave as expected. Division always returns floating point, which is basically just saying if you make division in Python with a single /, it returns a decimal floating point. And then if you do floor division with double, this drops the fractional part and returns the largest integer. So an integer is like just a whole value, and then this is a float. In other coding languages, besides Python, you have to go deep into other floating point doubles, and like there's different how much data you want to have in your floating points. But in Python, we'll just kind of keep everything really easy. Okay, so where were we? Or equal, and then there's the modulo operator, returns the remainder. Exponential operator raises to the left operand the power of the right operand. Okay, how to use it? So they're just doing a little simple thing here of area equals width times height. Perform the arithmetic, combine numbers and variables using operators. The total here is, looks like they're doing 50 minus 5 times 6. And we all know from math class that the multiplication here happens before the subtraction. And then they're doing a result equals, so this is just using parentheses before, happens before the division. And then here's a floor example. Modulo operator is something I don't think I've ever used at all in any application, but a lot of computer science algorithms may use this. So you use like the modulo operator if you want to like loop through something, and then if the result is, if the modulo operator equals 0, that means you're dividing it nicely without a remainder. This is raising to the 7th power with this double star symbol. Okay, so here's the type. So this is also using the type operator. Height and width. Why this matters. So variables make programs readable and maintainable using repeatable literal numbers everywhere you give them meaningful names. Basic arithmetic operators allow you to perform everyday calculations, such as computing temperature conversions, finding averages or scaling central readings, knowing operator precedence or the difference between floating point or the integer division will prevent bugs in your scripts. Okay, so this is our script. So it's already jumping into an F string here, I see. So we can talk about that later. Sometimes I like, if I'm trying to learn something, I actually think it's kind of nice fat fingering it by hand. So if I wanted to see this, for example, just setting up VS Code here. Okay, so yesterday video we ran a string just to print hello from Python, and then if you're new to VS Code, just get comfortable of like view terminal right here. So yesterday's video we talked about how to install, we installed from the Microsoft App Store. Let's see, what is that, Windows terminal. Yeah, so install this. This was like a neat way to make the command prompt look kind of like Linux, and it makes it much more robust. So definitely install Windows terminal from Microsoft App Store. Will be more just a better way of using things. So sometimes I like AI generated code if I'm trying to learn something. Sometimes I like typing it by hand. So let's just, I'm just going to do this here, where I'm just going to do this variation here on this side. Just do degree F equals, you can even do your own variation. So we're assigning degrees F to 77. You could say degree Celsius equals degree F minus 32 times 5 divided by 9, which is just the equation here for how to convert units from degrees F to degrees C. Then if we keep moving down, we can just say print degree C. And then I like just doing one of these. You just do degree C. Do a little colon here. So this will just print that guy. Okay, so if we just do Python math I don't know what we're doing here, script lesson, and it converted the values. Python just computed this just with math operators built into the Python coding language. No fancy math yet, and we won't get into that in this course. Fancy math, I mean, like if you're doing a computer science degree, which I don't have, you would get into linear algebra, matrix algebra, and when you're doing that kind of stuff, you would need like an actual math library. But we won't. Don't worry about any of that. We won't need it in this course. So like what they did here, this is called an F string in Python. It's a Fortran string. That's what F stands for. So that's like, think of it as a way that you can inject this variable right into the string, and then this is going into only do the floating precision of 1 when they do this right here. So if you see, another thing I noticed too is like since we defined, this is actually returning a float. So maybe we'll just do some random numbers. So look at how many floating numbers we have right here. So you can also do a round in Python. And if without passing in how many units you want to round, that'll just, I guess, round to an integer. But here now, if we use the round operator and we pass in a value of 2 to it, then we get 2 digits back. And if we want to round it, let's say to 5, and we'll get 5 digits back, or to the 5th, 5. Think of it as how many your floating decimal point precision. So they were doing an F string. So if we want to do an print, now we're getting kind of fancy. So if we were doing wanted to inject our value right into the string, we would do degree C in F string, and then we would use curly braces to plop that right in here. And if you really wanted to get fancy, we could do an alt 176, and that puts the degree symbol. This is the only shortcut I know in any symbols, is if you do alt 0176, that'll put a degree symbol. So that's an F. So this is an F string. If you see that right there, and then we can declare a string, and then with curly braces, we can inject our computation right into it, into the string. Whereas like our first example here, we just had a string and then we closed it with a comma, and then this is more typical. Like if we were playing around in C coding language, perhaps some other languages, maybe like Java, this is more classic way to print things, I think, is like you would do the string and then you'd end the string and then there's a comma and then print our value after it. But with a Fortran string, you can inject your value right into the string with the curly brackets, and there's no curly brackets up here. Okay, so I'm just gonna cheat and grab this because I think we got the basic idea. Oh yeah, and another thing they did too is I don't really use this very often, but I think this is like if you wanted to just say like your floating precision that you want your prints, you do a colon and then a 2F, something like that. and it did not print. Well, maybe I'll just move this away. And it didn't use that. So let's do. I almost wonder if that is interfering with it. So if we comment that line out. So in Python, part of the lesson was to comment out a line of code with a hash. And as you can see in VS Code, that it changes color. And it still didn't do it. Must be doing something wrong here. So if we do, like this should do it, but it's not. Wonder why that is. Oh, maybe I think I'm missing a dot here. There we go. So I was missing a dot right here. So that's our math computation, and then this is our our colon, and then to the dot 1f inside of the f string, inside of the curly braces, and then that's how you print. This is like the fancy way to, like if you were doing like an app, like a full production app, you would do this, and then but for our purposes and just playing around in something hacky, like if I'm doing some concept idea where I just want to basically play around with the code, I would just do this and like not even worry about any kind of, like if I'm just debugging a little program I'm making, I would just do this and not even worry about any floating precision or anything. But this is just to show you what it's like. Alright, then here's some other examples where they're just calculating the area and the width, a little bit more math. Okay, so now we're on to the micro exercises. Assign two variables A and B with numeric values and compute their product, quotient, and remainder. Write a small script that calculates how many seconds in a day, multiplication, and restore the results in the variable name seconds per day. Alright, so alright, I suppose we probably should do this, see if we can do this fast. A equals 50, B equals 23.3, maybe the same data types. Let's just make something up. So product, so if we do A times B, whoops, I'm just going to say product equals A times B, print product. And this is kind of like my fast way of just pumping something out. That's our product. So then say quote equals A divided by B, print quote. Just kind of make our print statements. In my prints, I always like to do a space right here, just so it makes a nice little space down here in our print. That's our quotient. So then remainder, I think, is the modulo operator. So remainder equals A modulo B. And it's 4. I think that's right. Remainder. And then if you always have second guess yourself, you can ask AI. You can even Google this stuff now too, which is kind of mind-boggling. You know, AI is built into the browser these days. So this is basically what it's saying. So with our numbers here, the modulo, this finds the remainder leftover divisions. Since 23 goes into 50.6 twice, the leftover is exactly 4. That's something I never really use, modulo operator, unless you're doing algorithms. Alright, so, and the same thing, that, and even ChatGPT is giving us some, you know, if you wanted to do this in fancy print statements, this is using the F strings, like we did down here. So these, I didn't spell things. Remainder. There we go. Okay, so I think we're done for today, which is kind of nice. I highly recommend this course that we're playing around here. Would probably get you enough to be dangerous with BACnet, and then if you combine it into a course like this, and then get further branch into software engineering or data science or whatever you want to do, coupled with AI, you know, anything is possible. I think the last thing, what do we got here? Compute 3, okay, so now this is just saying power equals 3. Let's see, 3/4 print power is 81. So then we could also do print, we can do this, I think you can do this right in an F string. I'm just going to call it manually. So we're going to do curly braces like we did before. And then we just do 3 times 3 times 3 times 3. So this is actually kind of the cool thing you can do with an F string, is you can put a little bit of math right inside of your string. So these are more ideal. You could also do it to the left, to the right of your string after the closing thing too. And you could even, you know, assign a variable. So manually equals I think if you're doing actually like real software engineering, you know, in advanced apps, you know, people would be doing F strings, because it's good for logging purposes. Like software engineers, like they'll, like how we look at trends of the HVAC systems, like how it operated over time. Like the software engineers, like they'll look at logs of how their app performed or crashed, and like when you make logs, I think this F string is kind of like what people would use for that. So it's nice to see that and play around with it. So I think that is all for today, and probably like one more thing just to be aware of in VS Code. Try and get familiar with VS Code, you know, watch some YouTubes, maybe even ask AI how to install extensions, but like if you see this tab right here, this is extensions, and like I think like what you want to use, looks like this is already depreciated. So there's like special VS Code extensions that help you determine if that helps you code in Python. And just type in Python and try and install these ones from Microsoft. Python environments, PyLance, Python debugger, and they'll just be like a little pop-up window that pops up here, but it makes it easier to code in Python. Like when I'm coding in Python, if I'm doing something wrong, it'll say like, ooh, that's an error, that's not defined. So there's a PyLance is actually flagging this. So like if we were doing, it's a helper tool. Like it helps you, it's like a smart IDE, a smart interactive developer for environment for coding. So when you install these Python extensions, it'll help you in your coding. That like it's a second pair of eyes that says, ooh, something's wrong right here, this is not defined, and then also it can suggest ideas how to fix it. So it helps speed things up considerably, rather than if you're just using Notepad++ or something like that. You don't have this stuff built into that that help assist things. Plus, like if you're like wanting to do like here, you just start typing, and like it can help you suggest like, oh, you're looking for that, and just make things a lot easier. Play around with opening up the terminal, and then you kill your terminal from here. If you need to kill your terminal for whatever reason, it would be like the same thing as like this. I'm opening up PowerShell, which I have on a different monitor. But if you go new terminal, voila, there you go. There's your terminal, and you can even do split terminals. If you wanted to open up two of them at once, you could have one app running on this side and one app running on this side. And then you can just kill them both by here. You can do everything through VS Code, which is kind of nice. Maybe as we progress towards the course, you can even SSH into your Raspberry Pi all through VS Code. So it's a pretty cool tool. So I think that's all I have for today, guys. Thanks for watching, and please post in the comments if there's something not covered or you need help with something. And if so, just post in the comments. All right, guys, I'll see you tomorrow for day 3.